Okay, so today we're talking about converting from the general to the standard form. And so last class we talked a little bit how to move from this to this by like foiling this and then multiplying it by A and then adding Q. So today we're going to talk about how to go the other way, from the general form to the standard form. And so what we do is called completing the square. So we're going to do some practice with perfect squares. So let's do this one right here. So if we were to expand x plus 4 squared, could someone put up their hand and tell me what it is? Justin? Perfect. So we'll notice that this is 4 times 2 is equal to 8. And we can notice that this is 4 squared. It's equal to 16. Because you go x times 4 twice. So you get 4 times 2 is equal to 8. Okay? So let's do this one now. So if we had x minus 5 squared and we wanted to expand it. Okay, so if you watch this, Andrew, you get x squared minus 5x minus 5x plus 25. And then that gives us x squared minus 10x plus 25. So we can notice that we go, okay, minus 5 times 2 gives us minus 10, minus 5 squared gives us 25. Okay, so let's do this one really quickly. So can someone put up their hand and tell me quickly what it is? Yes, Josh? You got it. 14x plus 49. So we can kind of generalize it by writing it as a, so we know we get, okay, x squared plus 2ax, because it's a times 2, plus a squared. And this one we get x squared minus 2ax plus a squared. Because when you're foiling it, yeah. So remember, we go do first, outer, in. Yeah. So if you notice that in all of these, this number here is always that times 2. So 7 times 2. Exactly. Okay? This is like, should feel like super review right now. Exactly. So we're going to do 2 quick problems on B. And so now we're going in the opposite direction. So we have the expanded form and we want to factor it into perfect squares. That's a good question. That's always the first question, right? Is there a GCF? And you can tell in all of these that there isn't one. Well, it's one is a GCF. Okay? So can I have someone with their hand up tell me what this is in perfect square form? Someone with their hand up. Kelsey? Perfect. X plus 3. Are there any questions over there? Then you should be quiet. Okay, and so if we do the next one, yes, Josh? You got it. Okay. Okay, so there's 2 ways you can get it, Michaela. You can go, okay, take the middle number and divide it by 2, or you can take the square root of the third number. Okay? The one thing you have to remember is that whatever the sign is here, that's going to be the sign right there. Okay? So now for C, we'll do this one first. Now they're saying, okay, we have to add a constant so that we can make it a perfect square. So what would the constant we add be? for this one. So someone with their hand up. Justin? Okay, so we have 4. So then what would our perfect square be? So would x plus 1 give you... Okay. So we can remember that it's like, okay, this divided by 2 and the square root of this. So we know that it can't be 4. So Sam, what can it be? 81? No, because we... Okay, well, follow what we're doing. Okay, so 2x divided by 2. 1, right? So x plus 1. Okay, so Sam, can you tell us about the one we're working on now, number 2? And then what's our perfect square? You got it, x plus 9. Okay, so let's do this one now. Okay, so so you divide this middle coefficient by 2, and that'll give you this part here. And then you square that number, and that'll give you that part here. Not for this one. So 9 over 4 is the constant, and x minus 3 over 2. Okay. We usually like you to keep it in fractions if it's not a whole number. Okay? Yeah. We would prefer if you keep them in fractions, because on a multiple choice, that's what your answer will be in, is fractions, right? Okay, so can I have a volunteer for number 4? Do we need to move one of you guys? Can you not handle sitting next to each other? Okay, so divided by 2, right? So it would become negative 1/8, right? And then when you square it, Andrew, what would it become? You got it. Perfect. So like I said, this should seem a lot like review, right? So this here is notes, but it's a lot more complicated. So you go b divided by 2, and then you want to square it. Okay, so that's kind of like our key thing. And we're going to be doing lots of examples with this. So, okay, so express y is equal to x squared plus 10x plus 16 in completed square form. So we're going to go through this step by step. So y x squared plus 10x. And our plus 16, we're not going to forget about it, but we're going to deal with it later. So I'm going to write it all the way over here. It's okay. It'll survive. So what we want to do is we want to take our 10 and we divide it by 2, and then we square that. And it does equal 25. So the next thing we're going to do then is we'll go, okay, y x squared 10x, and we're going to add 25 and subtract 25, because we know if we add and subtract the same thing, we're not actually changing the problem, right? It's the same thing if I said, oh, plus 1 minus 1. No, because we're adding it and subtracting it. If we were only adding it, we'd have to do it to both sides. We're moving it into the standard form. Okay? So one thing you should notice then about this Yeah, it'll equal the same thing because we're adding 25 and we're subtracting 25, right? But what we can see now, go like this, is now we have a perfect square here. Okay? So if I was to write the perfect square in factored form, x squared plus 10x plus 25, can I have someone put up their hand and let me know what that would be? Yep, Kelsey? Got it. X plus 5 squared. And then we get minus 25 plus 16. Yes, Josh? And like just factor it? Okay. Because we're not just breaking it into factors, we're putting it into standard form. Because when it's factored, it looks like x something like this, right? But we're not breaking it into factors, we're putting it in the standard form. Because the standard form tells us the vertex, it tells us the stretch, and all that. Whereas factoring it doesn't necessarily tell us all that. So that's a good question, though. Okay? And then we just simplify from here. So we get negative 25 plus 16 is equal to negative 9. Okay? And like most things in this unit, we can check it on our calculator too. So in y1, you can put x squared plus 10x plus 16. And then in y2, you can put x plus 5 squared minus 9. And then you want to make your y2 one of those like fat lines like that. Okay? And then you hit graph. And you can see that the two graphs are the exact same. Okay? Yeah, they should be the exact same. You got it. Okay? And so you'll get something that looks like this. Isn't that perfect? Okay? They're the exact same. Like, which form do you want to use? Yeah, this is just a verifier answer, so we'd say like identical. Yeah. Okay? So the reason you need to know how to do this is because the general form and the standard form tell us different things, right? So, Jackson? So on our standard form, we know like that the vertex is negative 5 and negative 9. We know that there's no stretch. We know that there's no reflection. But this will help us, I think it's in the next lesson, help us find our x-intercepts really quickly. Yes, Andrew. You always want to do the plus first, because for that perfect square, you know that 5 times 5 is always going to be a positive number, right? So that's a good question. Yes, Justin? This is standard. There is no A. A is equal to 1 in this question. Okay? So we'll talk about what happens when there's an A later. Okay, so for example 2. Yeah, it'll be example 3 and 4. Okay? Okay, so for this one, it's the same thing. We want to write our minus 20 way over here, because we're not forgetting about it, but we're going to deal with it later. Okay? So Aaron, do you want to move one desk up? Okay, so we'll go -2 or -9 over 2. And we can't really simplify that, so we're going to leave it in fraction. And we'll go -9 over 2 squared is equal to 81 over 4. You square both the top and the bottom. Okay, so then we add 81 over 4, and we subtract 81 over 4. Perfect. So now we want to bracket that. You got it. Okay, so we get that x minus 9 over 2 squared minus 81 over 4 minus 20. So you can notice that whatever we have here is going to be that number there, right? Because it's just always going to be this middle one divided by 2. So then we want to simplify it. Like this. And then, okay, so we have 81 over 4 minus 20. We know that's the same as 81 over 4 minus 80 over 4. And it's minus 161 over 4. Right here. Sam, right here. Yeah, so, because you divide it by 2 and then you square that number, right? Okay, so the second part of the question is they ask us to determine the minimum value of f by writing the function in standard form. So we have it in standard form, but we have to find the minimum value. And we know that our minimum and maximums are always at our vertex points, right? And we know that our vertex is P and Q. So we just go, okay. Vertex is 9 over 2 and negative 161 over 4. Okay? And we know that it's a positive 9 over 2 because it's like x minus positive 9 over 2, right? Which is why we stressed it so much earlier that you have like x minus something, okay? And then so if this is our vertex, our minimum value is negative 161 over 4 because it's always going to be the y of our vertex. Okay? And so how do we know that it's a minimum and not a maximum? No. Kelsey has her hand up. Yeah, so because there's no reflection here, we know that it's going to be a minimum. If there's a reflection, it's going to be a maximum, right? If there, got it. So our graph would look something kind of like this, right? Like something kind of like that. Okay, so now we're going to talk about what happens if there is an A value. So this is like, okay, if this was a factoring problem, this would be like a type 1, and we'll call these type 2. Because they have that A value there. So in a type 2 factoring problem, Justin, what's the first thing we look for? You got it. So the thing with the GCF here is that 3 doesn't go into 20, right? So all we're going to do is we take the GCF of the first two terms and just of the coefficients. Not bending the rules. So the coefficient is the number in front of the x. Okay? So it looks like this then, right? And then from here, we basically do the same thing. We go, okay, f of x is equal to 3, x squared minus 6x. And then we're going to leave some space here, and we'll put our plus 20 there. Okay? And then we go, okay, negative 6x divided by 2 is negative 3. Negative 2 squared is 9, positive 9. Okay? So then we go plus 9 minus 9 inside the brackets. Okay? So the next step is that we want to start completing our square, right? But we can't do that when we have a plus 9 and negative 9 in there, right? So what we're going to do is we're going to bring our negative 9 out of the brackets. So we go negative 9 times 3, and we stick it on the end. So it'll look like, okay, squared is equal to 3. And we go, okay, negative 9 times 3 is equal to negative 27. We go minus 27. Okay? So to get that negative 9 out of the brackets, you have to multiply it by that common factor. Yeah, because we need the positive 9 in there so we can complete the square, but we had to get the negative 9 out. Okay? And so Justin should be keeping his hands to himself as well. YouTube. Okay? So this is now something that we can factor into perfect squares. So what is our factors? Okay. So we get x minus 3 squared. And then we go plus 20 minus 27, so negative 7. Okay? And so from here, they say, determine whether the graph has a maximum or minimum value. So, do we have a max or a min? Yeah, Aaron? Okay. So the 3 has to multiply to everything inside of the brackets. So because we still have this here, we have to keep that 3 there. Okay? And to get that negative 9 out, we have to multiply it by the 3. Okay? So that's a good question. Okay. So because our 3 here is a positive, that means we have a minimum, right? So it's going to look like this. Our vertex is 3, negative 7. So it'll be like this. Minimum is 7. Yeah. Minimum is negative 7. Okay. For example number 4. Exactly. So our equation isn't in the form that we really like, but that's not a problem. All we have to do is write it in that form. So all you want to do is move it so we have our terms in the right order. Exactly. So this is like a type 2, right? So we go negative 2 squared minus 5x plus 7. So remember that when you're taking negative 2 from 10, you get negative 5. Not positive 5. Yep, Shannon? Yeah. So that's a good question. The last class asked that as well. They say, well, the real GCF would be negative 2x, right? But our goal is to get it to be a perfect square. So we need that x squared in there. Yeah, so it's like, we should actually call it just a CF, a common factor, not necessarily the greatest common factor. A little bit. Mathception. Okay, so we get negative 5 divided by 2. So it's negative 5 divided by 2. And then we want to square that. And we get 25 over 4. So we're going to add 25 over 4, and we're going to subtract 25 over 4. Okay? And then we want to get that minus 25 over 4 out of there. So we're going to multiply it by negative 2 to get it out of the brackets. 5 over 4 multiplied by 2 is negative 50 over 4 is equal to negative 25 over 2. Okay, so we write that as okay, so we can remember that we get that by going, okay, negative 2, 5. Okay, so the next thing we have to do is we want to simplify it, right? And the last thing to simplify is just this stuff at the end here. But everything inside the brackets is already dealt with. Okay, so we go, okay, 7 minus 25 over 2 is the same as 14 over 2 minus 25 over 2. Oh, you guys didn't catch it. Okay, so we had to multiply this. Okay, so we have 25 divided by 4 times 2, so it's 25 times 2, which is the same as multiplying it by 2 over 1. And you get 50 over 4. You guys didn't catch my mistake. Okay. So you get 39 over 2. Well, you can. I don't have a calculator up here. Okay, so we have 14 or 7 plus 25 over 2. So remember, if you're doing that in your calculator, like 7. No, that was a mistake I made. I changed it on the board already. Just remember to put that 25 divided by 2 in brackets. And then you can find it in fractions. 39 over 2. Okay, and then they say, in what direction does the parabola open? So does it look like this, or does it look like that? They're asking, does it open up like this, or down? Yeah, it's like a bridge. How do you know that, Justin? So the reason we know that it's upside down is because we have a negative here, which means it's a reflection. Okay? So the positive at the end is our y value on the vertex, right? So that means it would look something like this. This number at the front here is negative. No, if the number at the back was a negative, it would look like this. Then it would just be, that's like the coordinates of the vertex. So that just says where it is. What says what direction is whether this is positive or negative here. Okay, so one last example. Okay, so is this a type 1 or type 2? Okay, so I need someone with their hands up, and everyone else who doesn't should be absolutely silent, including you, Sam. It's always chilly in here. Okay, so it's a type 2, so that means we have a common factor. So we'll take that 3 out. Yeah. Okay. Okay. So then we want to go, okay, minus 4 divided by 2, it's negative 2. Negative 2 squared is equal to 4. So we go plus 4, minus 4. Okay? We want to get that minus